Hey, is the mic fine? Cool. I will try not to shout as I usually do. So, yeah, my name is Fredrik Korsbäck. People probably know me as Hugge from the internet, since there's actually where I live. I work for both NORDUnet and SUNET. It's quite a long story, but for the sake of argument, that doesn't really matter for now. So I'm going to try to do my best Job Snyder's impression here. He's the guy that usually does this from NTT, but he couldn't come, so that's why I'm doing this. And I'm here to speak about BGP for a change. Typically, I'm here to speak about optical stuff or building new network stuff, but now it's about operational improvements on the internet. And BGP Graceful Shutdown is a simple procedure to reduce the negative impact of shutting down a BGP session. And I think a few of you in here might think, what is actually the impact of that? You just shut it down and traffic reroutes. Yes, that is true, but it takes some time. And also why this is happening, some traffic is lost. I'm going to come into why traffic is lost. And I mean, this is, of course, I stole a lot of Job's slides here. So another thing here is shutdown communications, which can be used for this. And this is actually an RFC now. Which is really cool, and this is that you can tell other peers that you have through BGP what the intention was, why you shut it down. For example, sorry bro, we're not peering anymore, or we're doing a planned maintenance, we're done at 6 a.m. This exists now in BGP, which is kind of cool. What is not cool is that the vendors are quite slow at implementing this, so they're not actually compliant to the BGP RFC. Because that RFC updates the original BGP4 RFC. So that could be interesting. All right, another thing. This can also be a part, but it's not necessary, to do what is mentioned in the draft that is called BGP session calling. That is something that is mostly interesting for IXPs. And since we're at NetNode, I know that NetNode does this, and I also heard that Stockholm IX will also do it, so that's good. We don't need to talk more about that then. Then I guess we of course need to continue to push this throughout the IXPs in Europe and USA, of course, so that we can get session calling working to not lose traffic whenever we do maintenance or they do maintenance. But Graceful Shutdown is what this is about, and this is a make before break kind of thing, and it does not help against unplanned outage. The only thing we can do with unplanned outage is to not have them. And that will never happen, so that we need faster routers, and to get faster routers, we need to bitch more to our vendors to make faster routers. And this is not to be confused with the Graceful Restart, which I've seen on almost every presentation. This has been had. A lot of people has been confusing this with Graceful Restart, which is not, because Graceful Restart is kind of crazy. Anyway, context for this is when an organization decides to peer with another organization, it's probably because they want to exchange traffic in some way, either because they have a customer to operator relationship or an operator to operator relationship. This applies to both. It's equally useful both in the customer to operator and operator to operator situation. And if you happen to run a network that you want packet loss in, then you can probably stop listening and go take a coffee or read emails. But for the ones that actually like to not have packet loss, then please continue. All right. So when does blackholing happen with a vanilla shutdown? Or vanilla in this case is a regular shutdown. Your NOC goes in and types BGP shutdown. It could be in a peer group, it could be on a peer, it could be any type of version of this. And typically a network looks like something like this. So you have two AS border routers and you have a peer. It could be a multi-hop network or any type of network. So what happens is that the peer here in the green little bubble sends a withdrawal. It's like, sorry, we're going down. Or rather, it's not saying that. It's just saying, I'm down. The AS border routers will propagate this to the route reflector if you have one. Even if you don't have one, it will still tell another router that this path doesn't exist anymore. And but it's mainly when you have route reflectors. I think most big networks have route reflectors these days. So the route reflector typically, even if you don't run add path, it will only send the best path to all your routers. And suddenly this path doesn't exist anymore, but all the routers is still sending traffic to, for example, the border router to the right. And it just lost its peer, but it hasn't gotten a refresh from the route reflector, so it will just drop the traffic on the ground. These are called transient black holes, or that's actually what's called. even though they are short, it's not necessarily always they're short, because if we'll take any Swedish ISP, probably looks like this. So it's like an old Juniper router and an old Cisco router, and then Lehman's old Sun Spark station, which act as a route reflector. So this is not very uncommon. This actually happens quite a lot. And even if you have the more modern version of these routers and a more modern version of that Sun route server, they're probably still quite old. Maybe it's a month's old server. Anyway, so sometimes these things can take quite some time to converge. And especially if the peer you're losing is quite big. I mean, it could be 650,000 prefixes which you need a new route for, but the route reflector hasn't told you the whole story yet, so you're just waiting, but other routers are still sending you traffic, so just drop it on the floor. And then you can add another level to this, because I think, maybe it was at this conference, or maybe it was DKNOG, or maybe it was some other conference, where I was here shouting about BGP 38 and the Manners project, about that you should do RPF filtering, of course. And since that was a long time ago, I just assumed that everyone is now doing BGP 38 filtering or RPF checks. This makes it even more hard, right? So you have this old Cisco 7600. It has probably a 10-minute convergence time on a full BGP table. And if the peer below, let's say that's a quite big ISP. For example, we could say the peer down there is Telia. They probably have a big router, and they probably, since I told them to run RPF checks, RPF checks is, by the way, that you're not allowed to receive traffic on a port which you don't have a route to. This can be implemented in a few different ways. It can be RPF strict, it could be RPF feasible, RPF loose. Either way, you probably get affected by this, that you're not allowed to receive traffic on an interface which you don't have a next stop route to in your routing table. So this little Cisco 7600 up here, which has about 10-minute convergence time, it should receive 650,000 IPv4 prefixes from the upstream, whereas this ISP is only sending about 100. So the big ISP will converge 100 prefixes. That is done within 2 seconds or 1 second. While the Cisco box over there, it will converge in 10 minutes. And during those 10 minutes, it will black hole, unless the green little peer down there has taken a few precautions, for example, having failed filters and this. But typically, it's not part of the standard. So of course, there's hacks around this, but I would say that I think that most will actually just black hole the traffic. Okay, so what can we do about this? We can, of course, tell everyone to buy quicker routers. I think that Pedro somewhere here from Arista would like that, but that's not what's happening in real life. People still run these routers. So something we could do, for example, is to use what is mentioned in this draft, which is a soon-to-be RFC, if we get our will correctly through, which is going to happen. And that is that we do a graceful shutdown of the BGP session. The difference here between just shutting it down is that we first send out our routes with a special community, which is a IANA assigned community string, 655535:0. This is a well-known community nowadays for graceful shutdown. The only thing that should happen when, for example, the blue or the green sees this community coming in with the prefixes being announced is that, sorry, I'm soon going away, so you should probably consider me the worst possible path that you could choose from. Hopefully this ISP has another route somewhere. If it's a single home customer, then sorry, bro. But if you are multi-homed in some way, either through another transit or through peering or whatever, that path should win. Since local preference is one of the most powerful tools we have in the BGP Swiss Army knife, it typically wins over everything else. So the graceful shutdown, we trigger path hunting inside this network. It will take some time because there's still slow old routers, so they will, and this is still slow old route server. But if we do this, let's say 10, 15, 20, 30 minutes before a planned maintenance is about to happen, then these routers can take whatever time they need to do a convergence. So, and then route the traffic away, and whenever that's done, the interface should be completely empty out of traffic. You just shut down the session, and everything's good. So it's not a big change. It also is an operational change. This doesn't change the BGP standard in itself. So all vendors are already, by default, compliant, which... All right. right? There we go. So, the only thing is here is that we're injecting, this is like the logical step for a router to take when a BGP shutdown happens. So, before we send the cease notification is BGP session down. We will do the thing that is on the right, is that we send an update instead of sending a cease when we do shutdown, because this could be changed from the vendor's point of view, that we actually implement more functions in the command BGP neighbor, blah, 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 shutdown. Now, as far as I know, every vendor's implementation except one just sends a cease, and then we're good. This is the correct behavior. But it could also be that we do this, that we send an update with the community, with everything that should be announced on that BGP neighbor, tags it with the community, and sends an update. Then, of course, the other network needs to listen on this, because this needs to work in both sides of the link. But that's also why I'm here preaching about it, so that both sides actually do this. All right, some usage guidelines. What you need to do in your routing policy framework is, first, you need to match on the Graceful Shutdown community, that you put in your route policies, that I'm looking for this. And when you have looked for this and found this, then do local preference 0. If you follow the ITF mailing list, which I actually think that most people should do if you're interested in working in this business, this might change to that it's recommended that it is lower than your lowest local preference. 0 is nothing can be lower than 0, but it could also be, if you for some reason like the number 10, then okay, if 10 is the lowest you have, then okay, fine, do 10 then. And also that you do not strip the community when propagating the prefix, because this actually is mostly to help big ISPs to find a way around if you do not strip this community, because then you can find another path to this customer, because it could be a customer of yours you have, but that customer is also multi-home to another big tier 1 ISP, and then you might not program the route in. So if you don't strip the route, don't strip the community, that would be great. That could probably require a bit more work within the ISPs, because I think most ISPs typically implement strip star on the outgoing policies. So that might need to change so that we don't match that strip everything except this one. But next time I'm here talking, I'm going to talk about to not strip any community, because I think we can use BGP community for a lot of fun things. For example, geolocation, so that we don't need to rely on MaxMind for that. But that's next year's talk. Anyway, and also to send a Graceful Shutdown, because it's when you initiate the plan work on your router, you're going to upgrade from another version to the next one. You also need to think of this as, I think everyone is using, that runs an ISP of any size, probably uses ISIS overload. This is BGP overload, essentially. So you need to filter, you need to match your outgoing route maps or policy statements that you also send this. And this is quite hard and quite easy, depending on which platform you have. And also, of course, that you remove the Graceful Shutdown community when you're done. Otherwise, you won't get any traffic on the box. But I think that should be noticed from whoever is doing the plan maintenance. Right. And of course, you also need to wait for the whole convergence thing to happen. So that is why I think this could be a good thing to do before the plan maintenance. That's at least how I do it. Anyway, so in human speech, this is what Graceful Shutdown signals. It's like, hello, if you consider this path your best path, please consider considering this path the worst possible path there is. And if you find anything better, then please feel free to program the into your fib, and this path will disappear in a few minutes. And I think that makes quite a lot of sense, actually. So, configuration examples, in this case, so AWS XR looks something like this. So you have an if statement that if community matches 605.35 : 0, that's that local preference 0. And you implement this either in your peer groups or under the address family, whatever you feel like. On the Arista Brocade AWS Quagga free-range routing, it looks something like this. Also a quite short set of text, not very complicated to implement. And on the Nokia Alcatel version, it's also quite easy. Same goes for Junos. This is from a router that I operate. It's actually a ComHem peering, where we apparently pair with them. So it's not very hard to do this. And especially like in Junos, where you have stacking route maps, it's very easy to implement this. Um, Then we have another weird one, which is iOS XE, which is actually implemented this the correct way. I'm not sure why. Cisco has been very involved in this RFC or this draft from the very beginning, but then they stopped. And now it's essentially the community that is driving this draft into RFC status. But they kind of invented it, and they built it for iOS XE. I'm not sure if anyone is actually using iOS XE on the internet, but this actually works pretty well, that it actually does this, that you can set a Graceful maintenance under the address family. And then it does exactly what it should do, that it sends out the community, it waits for quite some time, and then sends out the cease, and then the BGP neighbor is down, which is kind of cool, which is totally up to every vendor to implement as they wish. It's not required through the RFC, but it could be a quite easy thing just to mask the whole set community blah, blah, blah thing in route policies to just have one command that says, Graceful maintenance, activate, done, like ISI's overload. So let's look a little bit on what it looks, for example, in my network. In the NORDUnet's global peering network, we think it makes sense, and also we actually had a few complaints about this. I think we have a few Norwegians in here which sends us very detailed data from time to time that suddenly we lost Amazon here for 35 seconds. Why was this happening? It was like, oh, we kind of bounced up here. Like, oh, sorry about that. So it would be great if we could do this without anyone noticing, which is why I started to be interested in this, and this could actually be something useful. So we, of course, honor the well-known community on all BGP sessions, both towards customer sessions and also peering partners that we have. And for any prefix to AS2603 with the community, we will lower the local preference to 0 to facilitate the maintenance, to try to empty that link of traffic. And of course, then with the lower local preference, we will trigger path hunting for a new path to that prefix, and hopefully there is some kind of path to this one. All right, so what about you, all the guys in here? Because this is quite a killer one, right? Would you allow NORDUnet and others to perform hitless maintenance by honoring the Graceful Shutdown community? It might sound like a no-brainer from the beginning. It's like, why shouldn't you, right? But there is some kind of idea here that you should never honor any community at all, or any type of traffic engineering type of play here between settlement-free peering sessions amongst operator-to-operator relationships. Like an operator to customer, that makes sense, because the customer always know what's right, and the customer pays money for this, so of course the customer should get what the customer wants. But in this case, I'm not a customer of Comhem, and they're not a customer of me. We just agreed to peer with each other because it's mutually beneficial for us. Should we allow this? I think, being from the new school, I think that, of course, this is just good for everyone. Sure. There is definitely a small, so people could use this to do traffic engineering, could do this to try to, have the other ISP send longer bit miles. The concept of bit miles is a bit weird. I think it's actually like a cogent concept from the beginning, but it's like, you don't want to transport bits longer than you actually need to. With this community, you could actually do that, we send out the community for a few prefixes on this specific location, then the traffic needs to route around the globe and then come back to us, and that will negatively affect those guys. So of course there is a little glimpse here of yes, this could be done. But I think the solution to that is then, all right, let's monitor this. Let's monitor how much of this community you see, because I would think that most ISPs and operators in this room already monitor community usage, at least from the customers, like different DDoS communities or traffic engineering communities or route target redirect communities and all this kind of thing. So let's just monitor this as well. If this happens from a certain ISP on a lot of weird times, then it could be something to investigate and actually talk to them directly. And and also, of course, the implementation of the receiving side is easy on essentially anything that speaks BGP. The sending could be a bit more troublesome, but I would say that I think everyone in this room is smart enough to actually be able to figure this one out. We have a few networks. This is, for example, the global ones that does this already. We have GTT, GitHub, Entity, Coloclu, Bit, Comham, and a few more. And if you take that down from a global scope and actually look a little bit more about Sweden. So, as you know, I'm chairman of SOF, and I want everyone to be involved in that, of course. We have discussed this both on mailing lists and discussed it face-to-face, like on these type of meetings. And I think that everyone is positive about this, and that's why we've also been able to get support for a few more. For example, NORDUnet and SUNET, which I represent quite easy. Comham is doing it, DGC also doing it. And TLA is going to implement this quite soon, which I think is extremely good. Tele2 has agreed, thinks this is a good idea. SVT has said, yeah, sure, let's do this. NetNode will also do it for any cost services. Bahnhof has also put the hat in the ring. So I think if we could get this going, for example, for all ISPs, and also all small customers, because this is not only for peering on the exchange, this is also to everyone that has a customer, this is actually useful for your customers. Because then you can also implement the same thing. For example, if you're a dual home customer, you can say to that customer, if you listen to this community, then also please do this so we can make hitless maintenance for the customer, which is excellent. And how am I on time? Yeah, that's the time. Okay. And there is, of course, some science behind this. If you really want to read on some papers, these are two actually quite old, because this is not a new problem, because the routers were slow also back in 2011 and were even slower in 2008. This could be interesting. I think everyone actually knows this, that you get these transient black holes, and with the routing table getting bigger and our routers not getting faster, we're going to have more of these black holes, which will last a longer time. And with also the world here, I mean, if you're working with streaming, for example, we have a lot of streaming on our network. I mean, people get really upset when they have even 2 seconds of breaking the stream. So if you have slow routers, maybe you have 5 minutes, and I don't think that anyone thinks that is acceptable. That is actually the last slide I have. I'm a bit in front of my schedule, which is good. So questions about this? If anyone like, oh, what does this actually do? Please contact me here, or mailing list, or IRC, or catch me in the pub. And yeah,
do you want to take a few questions now?
Sure, of course.
If we have time for a few questions now, if anyone wants to discuss this, or are they waiting for the pub?
Everyone, yeah, I'm also waiting for the pub, so I'm totally cool with not taking
Okay, well,
questions.
can you join me in thanking Hugge?
No problem.